Today we will be studying the basics of strabismus, which is also called squint or deviation of the eye. It can be inwards or outwards. Inward is convergent squint and outwards is divergent squint. So, for example, this is an eye. ये nose हुआ तो अगर ये इस तरह है this one and this one eyeball is this तो it is left convergent eye, left eye, right, okay, left convergent eye or left esotropia. It is also called esotropia. If it goes out, then it is divergent squint or exotropia. These are the terminologies. Okay. Now, what is the basic principle of squint? And what is the basic principle of binocular single vision? What happens in squint that in normal conditions, when I am looking, for example, straight away with both eyes open, I am using my both eyes and I am having or I am enjoying binocular single vision. Binocular single vision. But that is by using both eyes. In squint, it is defined as dissociation of the misalignment. To be precise, if we define strabismus, we will define it as misalignment of the visual axis. That is, these are the two eyeballs, and what happens in misalignment? One eye becomes deviated inwards or outwards. Anyone or both can alternatively do it. Okay, so it is called misalignment of the visual axis, and in squint, it is manifested. Manifested is as the name suggests that it can be seen with naked eye. Later it is which is hidden. In manifested squint, the patient loses the binocularity. Binocular single vision is lost. What are the advantages of binocular single vision? Yesterday I taught you about ophthalmoscopy, and I told you that in the difference between direct ophthalmoscope and indirect ophthalmoscope, that the direct ophthalmoscope is uniocular, and I told you that it cannot it is difficult for the examiner to detect the raised lesion. Do you remember? And I told you when we use the indirect head mounted ophthalmoscope, we use both eyes, and with binocular vision it's easy for us to assess a lesion which is raised from the retina. That is, depth perception is lost, or which is also called stereopsis, that is lost. So these are the disadvantages of not having the binocular single vision. It is very important to have the binocular single vision. Now, how will we examining the patient coming to you with squint? We perform a test which we call Hirshburg test. Hirshburg test. You can confirm the spelling, okay? I hope these are correct. Now it is very easy and very you can say uh, give you a lot of information. What we do, this is the eyeball, this is the eyeball, right? So I make one eyeball divergent. Okay. Now we in Hirshburg test, this for example, this is a torch. We show the light into the at 33 centimeters into the patient's eye. Like ptosis, did you have ptosis examination? MRD,
Yes.
in which the corneal reflex is which is produced by the uh, light torch. You will measure the distance between the upper eyelid and that reflex, which is called marginal reflex distance (MRD). In this case, we show the light and the corneal reflex is produced. So the corneal reflex will be in this eye will be produced in the center of the cornea, right? In this eye, it will be if the squint is that much which I have drawn, it might be making a reflex here. So it is also this is nose, so and this is limbus. So you can say the reflex is being formed on nasal limbus. Understood? This is limbus and this is pupil. This is pupil. This is limbus and this is sclera. Understood or not? Clear? Limbus is a junction between the cornea and the sclera. This is the cornea, okay? And this adjacent part, which is the white part, this is limbus. There is no as such demarcating thing. Simply is this that where the cornea ends, the limbus starts. Where the cornea and the sclera starts, the junction between the sclera and the cornea is the limbus. Okay, it is very important anatomical structure. So this is the limbus and this is the pupil. So we have shown the light and the light reflects on the left in the left eye is made on the nasal part of the limbus. Understood? Understood? What can be the other possibility? If it is less deviated, for example, like this, then this is on the center, and this instead of limbus comes slightly inwards and it forms at the uh, nasal margin of the pupil, right? Got it? If it is less deviated, then it will be here, but it is still deviated. So if it is a little deviated, for example, and what is the other possibility? Uh, Not here, here. That is between these two. This is somewhere like here. Okay. This is at the temporal limbus. This is at the nasal limbus. And here, what is the third option? Between the these 2 points, that is not on the limbus, not on the pupillary margin, but between the limbus and the pupillary margin, that is here. Is it understood by all of you? Huh? Because these are very basic things, and these are though crude methods, but these give, as I told you, a lot of information. Now, if the uh, reflex is formed at pupillary margin, okay, it is mild deviation, mild outward deviation, and uh, this is at the pupillary, if it is at the pupillary margin, then with experience and observation and studies, we see that the eye is deviated almost 15 degree. This is a, you can say, it is already, you should remember this. This is a rule of thumb, almost a universal fact. If the deviation is at the limbus, the, it will be almost uh, 45 degree, okay, and in between the two it is 35 degree. These three things are the figures which you should remember. Now these are in degrees, and squint is the displacement. The eye is displaced from the center point to the lateral side, or it comes inward. And as the refractive errors, the refractive errors are measured in diopter spherical unit or and diopter cylindrical unit. For example, some person might be having a number of -2 diopter spherical slash -2 diopter cylindrical at 180 degree axis, right? And that is the refractive errors. But while we measure the when we studied ptosis, it is measured in millimeter. Its unit is millimeter, and the unit of measuring the squint is prism diopter. Because if you remember the physics, the displacement, there was a topic of displacement in physics. Do you remember? So then you must be able to recall that displacement is measured in prism diopter. Do you remember? So it is measured in prism diopters. Now it is also one thing, 1 degree is equal to 2 prism diopter. This must also be remembered. It is also a universal fact. So if a patient has got 15 degree, he will have 30 prism diopter of displacement or squint, 70, 90. Okay? I will confirm this is at the pupillary margin 15. I am a little bit unsure about these two figures. This is 30 or 40, whatever, but I will check it and let you know. For these three figures, you people need to know. So this is the Hirshburg test. The opposite of it can be that the eyeball is here. It will be, this is not lateral, exotropia or divergent, and this is esotropia or convergent. The other measurements are the same, okay, either on the limbus in between the pupillary margin and the limbus, and here the pupillary margin will be temporal, not nasal. Got my point? No? So this is the Hirshberg test. Very simple. Um, that's why I am making this video. Sometimes when you study it at the first time, it becomes sometimes confusing, and after looking or watching the video a couple of times or reading, you will become uh, conceptual in whatever what I'm saying. Now we come to the second part of the squint examination. Yes.